All right, you guys, hello. Today we're going to be talking about rotations. This is day 3 of our guided notes that we're working on. Okay, so let's define a rotation. It is a transformation in which a figure is turned about a fixed point. And a fixed point is just like a predetermined point. We're really just going to be focusing on the origin, making it nice and simple for this time around. Um, but it won't be like changing throughout the transformation. It's just one set point that we have. Okay. The angle of rotation, we are going to be rotating counterclockwise unless otherwise stated. So we're just going to say counterclockwise unless noted. Okay. And it also will give you a certain angle. We're really just going to focus on 90 degrees, 180 degrees, 270 degrees. And if it rotates 360, we're just back where we started. So really just focusing on those three is what we're doing this time around. Okay. The center of rotation, that's the center point that the image rotates around. And we have this little diagram. We have this triangle R, apparently just called R. And we are rotating it 40 degrees counterclockwise. This is the center of rotation. So we're basing that rotation on that point right there. Okay, and that would be 40 degrees. Let's look at this problem. Okay, for basically all of these, can I see that? Hold on, it's not moving on my screen. There we go. Okay, cool. I'm going to scroll to the next page real quick. Basically, all of these, we're going to be relying on these notes that are on the next page right here, these coordinate rules for rotations about the origin. Okay, so if we're starting with a point A, B, then if we were just to rotate it 90 degrees, then the new point would be at negative B comma A. And mostly every time we add 90 degrees to that rotation, so like this is an additional 90, this is an additional 90, it's like A and B are switching places every time. And I know it looks confusing looking at like which one is negative, which one is positive, but honestly, you can probably tell which quadrant something's going to land in. So let's say if we started at A, B right here, and we're only going 90 degrees that way, we know it's going to land in the second quadrant. And in the second quadrant, we can only have negative x values. So this negative b, I'm going to write negative x so that we remember, and positive y values. That's the only thing we can have there. So if you're getting a little tripped up on like, is it going to be turning negative? Is it not? Just know that for 90 degrees, A and B, or basically X and Y, they're going to switch places. And then think about what are the kind of numbers I'm going to have there. Can I have negative X's or will I have positive X's, negative Y's, positive Y's? Here we only have negative X's and positive Y's. Okay. In this third quadrant, sorry, hold on, my charger dropped. Ugh. Did I stop sharing my screen? No, okay. It just looks weird on my. We good. Hold up. This is like super in. Hey, sorry. I had to fix something. Um, for the next quadrant, this is the third quadrant. You only have negative X's and negative Y's here. And notice how when we went 180 degrees, it's like we went that 90, they switched A and B, and then like they switched again. So we're back at A and B. You only have negative numbers in that quadrant. So if it's going to land there, negative numbers, okay? And then this fourth quadrant, they're going to switch back again, be A, or like y comma x. And you can only have positive x values here and negative y's. Okay, so like don't stress so much about which one's becoming negative, which one's becoming positive. We can kind of estimate where something's going to land based on the degrees we are given. Okay, and just know how many times have we needed to switch the A's and the B's. And we'll practice that. And again, you will have a test in which you can use a front side of a note card. If this is something you're struggling with, it could be a good thing to add to that note card that you can use on the test. Okay. Okay, let's go back to that previous page at problem number 1. So we are going to graph the triangle ABC with vertices at 3, 0, 4, 3, and 6, 0. Okay, so let's graph the first one. 3, comma 0 is right here. Let me do it. 3, 0, 4, 3, right there, and 6, comma 0 here. I'm going to label my points A, B, and C. Okay. And we're rotating 90 degrees and we're going counterclockwise. Remember, it's counterclockwise unless we say something otherwise. Sorry, my charger keeps falling. Okay. And we can kind of see that if it's on the x-axis right now, like this A and C are both on the x-axis, for rotating 90 degrees, those are going to land on the y-axis, just straight over, okay? So that one we can see a little bit easier. So if A is at 3, comma 0, A prime, so if this is 3 over this way, then we gotta be 3 right here. And it's again that like switching rule, so we're gonna have 0, comma 3. Okay, technically that 0 would become negative, but we're right on the y-axis. We're not gonna have a negative 0, so it's just 0. Okay, similarly with C, so C is at 6, comma 0. C prime would be at 0, comma 6. They're going to switch places. But again, we can see that if it's 6 over here, we're got to be 6 up right here. Okay, so that one's C prime. And let's do B. So B right now is at, what is it, 4, comma 3. Okay. And you see, and I'm trying to talk about like why this is, why we just, like we do have a rule that we can just trust and rely on. But like, how are we seeing those rules showing up? So right now we see that this triangle, it currently has a height of 3, right? So we need to maintain that when we're rotating it. So for this one, and if we're looking at the rule, so B prime, you switch the A and the B. And remember, I can only have negative x values, and I know this B is going to land in this quadrant. It's not going to go any farther if we're just going 90 degrees. Okay, so we know that we're going to switch the A and B, so this is A and B, and that has to be a negative 3, okay, because we can only have next negative x values there, and then that positive 4. So we're going to go here, we're going to go over a negative 3, up a positive 4, and put a dot, and that's our triangle. Okay, this was A prime, prime, B prime, C prime. And notice how it still has that height of 3. We maintained that height. So that's kind of why we're flipping positions of A and B. It helps us to keep things consistent in our shape. Okay. And that's it. That's it for that problem. This is the B is the one that we really had to think about the rule. But the other ones we could kind of see how turning it 90 degrees is going to work. Okay. Let's go to the next one. Okay, so we have another triangle. It's at 3, comma 1, so let's graph it. 3, comma 4, and 1, comma 1, right here. Okay, and it says we're going to turn it 180 degrees. So that's like we turned it 90. Remember, when we only turn it 90, A and B are going to switch places. You turn it 90 again, they're going to switch places again, which is almost like they didn't switch places at all. And if you're turning 180 degrees, that's going to land you in this quadrant. Okay, 2 quadrants away. Whenever you turn 90 degrees, it's only 1 quadrant away. 180 will be 2 quadrants away. 270 will be 3 quadrants away. So that's how you can kind of keep track. Just it also helps you double check that you're landing in the right spot. Okay. So for this one, I know A and B are going to stay in the same places. We can only have negative X and negative Y values here. Okay, so we really don't have to stress too much about all the switching. Okay, so let me label my points. It's always good. A, B, C. Okay, so let's do A prime, B prime, C prime. Right now, A is at 3, 1. Now it's going to be at -3, -1. A and B don't switch places for this one, but they do become negative. So -3, -1. Okay, B prime is at 3, 4. They're going to become negative. So -3, -4. -3, -4 right here. Okay, and then C prime is at 1, 1. Oh, C was at 1, 1, but they're going to be negative. So -1, -1. My bad. Okay, so they're going to land right here. There we go. Okay, so we got A prime, B prime, C prime, and we see it's turned 180 degrees. Not too bad. Okay, I know this one is probably the harder of the three, but really we're just focusing on the origin. And if you remember these like simple rules, just remembering what quadrant you're going to land in, that's going to help you keep track of whether your X or Y are going to be negative and how many times you need to switch the A and the B or the X and the Y spot. Okay. Cool, let's do number 3 on the next page. This one's a little bit blurrier on my screen. I'm sorry for that. Gotta look on my paper to see it a little better. Okay, this time I have a quadrilateral. RSTU, and R is at 3, 1. I'm going to do my best to get it in the right spot. 3, 1. And then 5, 1. 5, -3. And 2, -1. We've got kind of like a weird, maybe trapezoid looking thing going on. Let's label our points. R, S, hold up. Yeah, S, T, and U. And this time we're turning it 207 degrees. So that's going to be, that's going to be 3 quadrants away. Notice how we're kind of spanning 2 different quadrants. We have some R and S are in quadrant 1, and then U and T are in quadrant 4. So each of those are going to land 3 quadrants away from where they are now. So I know that RS is eventually going to land 1, 2, 3 quadrants away into quadrant 4. Sorry. Ah, go away, go away, go away. And then U and T will be 1, 2, 3 quadrants away in quadrant 3. So that'll help me keep track. And because it's 270 degrees, they're going to flip. The A and the B's are going to flip. Okay. So let's think about R prime. Currently, R is at 3, 1. A and B are going to flip, so I'm just going to write the 1 and the 3, and then I'll figure out what needs to be negative in just a second. Okay. If we're doing R, and that's going to land 1, 2, 3 quadrants away, we're landing in here somewhere. That's not the actual point. I'm just trying to, you can't see where I'm pointing with my actual finger, so in this area is where we're landing. We only have positive X's and negative Y's there. So we're just going to make this 3 negative. That's it. Okay. We know where R is going to land. We know that we had to switch the A and the B. And so we know in that specific quadrant, we got a positive X, a negative Y. That's just how that quadrant is. That's the features of that quadrant, okay? So that's going to be R prime. But I'm going to figure out all the points and then we're going to graph them because it's going to be a little bit close to the other shape and I want to be able to point at things along the way without covering the picture. Okay. S prime, we know we're switching A and B. So we're going to have a 1 and a 5. And because R and S, they're along that same line, they're landing in that same quadrant over here. Over here. Over here. Yep. Cool. And then we're going to have a positive X and negative Y again. So we're at 1, negative 5. Okay, T prime. Right now we're at 5, negative 3. I'm going to flip them. So 3 and a 5. I know the 3 is already negative. I'm going to kind of ignore it for a second because we need to decide what quadrant it's going to land in and which ones are going to be positive versus negative. So just for a sec, I'm going to pretend like they're both positive. Okay, and if I'm at T right here, right there, and I'm landing 3 quadrants away because 270 degrees is going to be 3 quadrants away. 1, 2, 3. I'm landing in this third quadrant here right now. We only have negative x's, negative y's there. So it doesn't matter what it was before, it's going to be negative when we're landing there. So negative 3, negative 5 is what it's going to be. Okay? Same thing with U. It's in that same fourth quadrant as T. I'm going to switch the A and the B spot. So it was a 2, negative 1. So I'm going to make it a 1 and a 2. And they're both going to be negative because we're landing in that third quadrant where we only have negative x's, negative y's. Negative 1, negative 2. Okay. Hopefully thinking through it this way is a little bit easier than like writing down the rule and being like, okay, it's already negative, I need to make it positive, or when do I make it negative and positive? Just rely on that structure of the graph. It should help you through it. Okay. I'm going to erase some of this extra bits that I drew on here for helpfulness so that we can see the final shape. Okay, so R prime is at 1. I'm going to switch colors because this one's kind of close to where we were. 1, negative 3. It's right there. 1, negative 5. Negative 3, negative 5. And negative 1, negative 2. And we're going to label our points. So R prime, S prime, T prime, U prime. We did it. Okay. So remembering 90 degrees, when you rotate 90 degrees, it'll be 1 quadrant away. Or if you're on an axis, it's just on the next axis. Okay. 180 will be 2 quadrants away. 270 will be 3 quadrants away. Okay. Cool. We're going to go to the next page. So again, make sure, like, if you want to write down these rules, you can, or if what we said makes sense. I don't know why I said we, like there's more than one of us talking. There's not. It's just me. Okay. But still. Sorry, my dog just snored and it distracted me. Okay, we're going to do a composition like we've been doing with the other ones. So again, we're just going to be having a line segment at negative 4, positive 4. So that's right around here. And negative 1, positive 7. Right there. Oh, can draw straighter than that. Hold on. Close enough. A and B. So we're first going to translate our function. Okay. Remember when we have x minus 2, that's going to be a left 2. And then y minus 1 means down 1. Okay. So let me change colors. We're going to move each of these left 2 and down 1. 1, 2, 1 right there. And then 1, 2, 1 right there. So pretty close to where we were already. We got A prime, B prime. And we're turning 90 degrees about the origin. Remember, we're going counterclockwise unless otherwise stated. Okay. So I know that that's going to land in this quadrant down here because if I'm just turning 90, it's one space over. And I think it's going to be more helpful if we actually write out the points from this transformation So if we were at A prime, that would be at -6 and then 3. You can either look at the graph, or I'm just subtracting 2 from this -4, 1 from this +4 from the A value, okay? B prime is at -3, 6. Okay, so if we are going to find A double prime, switching colors real quick. A double prime. Okay, we know when we're turning 90 degrees, A and B are going to switch places. So we're going to have, for this one, we're going to have a 3 and a 6 from right here. Okay, again, I'm not starting off with them being negative. I know in this quadrant, I only have negative x and y values. They're actually both going to be negative, okay? So I'm just going to throw that on after I realize what quadrant I'm landing in, okay? Both negative. B double prime is at -3, 6. I'm going to switch their places, and they're both going to be turning negative because of this. Okay, so it'll be at -6, -3. And then we will graph those points. So we have -3, -6 right there. And then -6, -3 right there. Oh, and we should connect. Okay, there we go. We did composition transformations. I first translated it and then rotated it. It's really going to help if you write out the points and then where they're going to land with rotations. So, like, translations are really easy to eyeball. This one's not as easy. If you have a method that works, that's great. Normally that method works a little bit when you're doing it on a physical paper, but the test will be on a computer and it's going to be hard to, like, rotate your screen. So just be careful, okay? Let's do this last one together. Ooh, it's a little blurry too. Okay, so T is at, we have a triangle, so T is at 1, 2. U is at 3, 5. And then V is at 6, 3. Label the points. Okay, this time we're doing the rotation first. And it's 180 degrees, which means A and B will not switch places. But we need to see what quadrant they would land in. So if I'm currently in this quadrant, 180 degrees will be 1, 2 quadrants away. So we're landing in this bottom quadrant, so I know all of my values are going to be in negative x's, negative y's. Okay, and they're not switching places. So let's figure out where we're landing. We got, let me switch colors. So T prime, if we're at 1, 2 right now, -1, -2. U prime is at 3, 5, so we'll be at -3, -5. V prime, this is at 6, 3, so -6, -3. Okay, and then we're going to graph. 1, 2, 3, 5, 6, 3. Okay, and label T prime, U prime, V prime. Okay, that looks good to me. Now we need to reflect, so we're going to do a reflection this time across the x-axis. So that's going to be across this line. And there was rules about with the x-axis that was on the previous notes. But again, we just need to be equal distance from that line of reflection. So right now, T prime is 2 boxes away. So we need to go 2 more boxes up. And T double prime is landing right there. U prime is 5 boxes away from the x-axis. So we're going to go 5 boxes up along that same line. Label. V prime is 1, 2, 3 away. We're going to go 1, 2, 3 more. V double prime. And we did it. Okay, we first rotated and then we reflected. And that's it. Okay. I know the notes say let's go to page 727 in our book. I borrowed this from another teacher. Don't worry about it. Your assignment is located right behind this paper. So that's what you're working on to practice these rotations. The rotations are a little bit trickier, so make sure you are putting in the practice. We'll have one more day of notes, and then your test will be online the next day. There will be no review day, so make sure you are preparing the note card that you want to use. That you're studying, you're practicing, you're using your time wisely, you're supporting each other as classmates. Okay? If you're done, make sure you're working on the additional module. It's due May 20th. That is the last day it'll be accepted. No late work for that. Okay? It's the end of the year at that point, and we can't do that. Okay? All right, you guys got this. I believe in you. You're doing great. Have a good day. Bye.